Okay, so I'm going to talk about LDAP in SuriCata. So first of all, a few words about me. So I work at ANSSI, the French cybersecurity agency. I'm also an open source contributor, and I feel old saying that, but a long-term SuriCata contributor right now. And I almost feel sorry to make a lot of people have to learn Rust right now. Sorry for not feeling that sorry. So I customized a SuriCata with the clown nose, so we are in the feeling. So today's topic is about LDAP, so we're going to have a few words about that. I'm not going to read my slides. I believe you can do so. I'm trying to do something which is not really usual to me. I'm trying to speak more about the why and what we can do with LDAP support in SuriCata and not the how. I'm a technical guy. I would have loved to talk to you about the how I parsed ASN1 and stuff like that. But I tried to avoid you the technical details. And also, since I'm a technical guy, I failed. So there will be technical details in the presentation. An important point I would like to raise first is that often I see intrusion detection focused on perimetric detection. You know, you're monitoring what's going outside and inside of your network to the internet. Of course, it's important because it's the point where the first point where you can see intrusion, data exfiltration, and so on and so on. But it's becoming less and less interesting with hopefully people are now using encrypted connections, so sometimes it's not that interesting to have a look at perimetric supervision. And also, we want to do more. So to do more, we're trying to focus onto internal supervision. This kind of monitoring is really interesting because it will show you not only the attempts to compromise something, but when it has succeeded, which is something interesting to know, of course, you will also be able to try to detect lateral movement, which is really important, and so on. Something important, it's complementary to perimetric security, so I will never say remove your sensors from the outer network and so on. It is complementary. Do perimetric detection first and then focus on the inside. Also, there is a kind of trend where tools like SuriCata are not always used for IDS rules all of the time, but also for the logging features. For example, you can log a lot of metadata, which are not by itself intrusions or malicious behavior. But when you log it, then you open the door for other tools to be able to analyze this data and to do, for example, anomaly detection, behavior analysis, and other buzzwords using AI you may put on that. So in this talk, I will try to focus on what we will be able to do, the current status of the LDAP app layer, what we will be able to do, what we intend to do. Well, let's see. So first of all, the location. LDAP, I will give some details right after. LDAP is often used in Active Directory. So to capture LDAP traffic, the most interesting location is just nearby Active Directory domain controllers. Which is nice. It may be more complex than that in real life deployments because AD, Active Directory deployments can have delegation, multiple controllers, and so on and so on. So you may have some pre-processing to do to join traffic or to filter duplicated traffic or to do stuff like that. It's quite complex. Also, we're talking about very, very verbose queries. an AD controller is very, very active. And not only during the entire day, but also in bursts when people are logging in on the morning, or maybe not so the morning if you're in Spain, but anyway. So there can be some other problems to solve. Yeah. So a few words about LDAP. So LDAP is an old guy's thing, you know. It's from the 90s, 8-something year. The latest standard is from 1997, so we are talking about old stuff. So yeah, great RFCs, great stuff to do. Its definition is application protocol for accessing directory services. That's not really a definition, so I'll give someone better like that. The common uses is storing data for enterprise directories, like, of course, address book, but authentication databases, name servers, and so on, and of course, Active Directory. So LDAP is many things. It's a network protocol, which we'll talk about, but it's also a data structure, which is a tree. By the way, I don't know why IT folks always represent trees upside down, but well, that's just something I wonder. It's also a text format, a language for queries, so you can also do stuff like trying to filter queries like SQL queries, but these ones are much more complex. We'll see. It's almost everything, but not about the database. So if you think of Active Directory is LDAP plus Kerberos plus a few paint on it. It's just stuff like that. It's just standard protocols. So the software that is interesting to look at is mostly Active Directory, OpenLDAP, and other LDAP servers. I will go fast on that. You'll have the slides. It's not really interesting. Let's go into the interesting part. So in terms of protocol, it's both TCP and UDP. I don't know why, but it seems also that every protocol designer tends to design new protocols with fragmentation features. There is no need, since the underlying protocols already have fragmentation. So message to protocol designer, stop that, please. There is no need. The regular port is 389. There is also SSL TLS, but not always, as we'll see. There is another port for Active Directory. And there is a notion of request and response. So, yeah. Globally, the client makes a request. The server gives a response. We have to parse that. The difference with recent protocols is that there can be many different requests in the same session. There can be different users in the same session, so different authentications and things that are quite, unusual. There are also extended operation, which is the word everyone used to say stuff that wasn't in the RFC. So this is me looking at the specification. Of course, the gory details are, it's based on ASN1. So parsing this is a minefield. It's quite complicated. Usually it tends to make people become crazy. I was lucky. I already was crazy, so it's okay. It should not be worse. It's based on something, if you know, ASN1 is a text description of what you can find in the protocol, and then you have the encoding. The encoding is usually BER, which is the you do whatever you want, and DR, which is the you have only one way to do something, okay? And of course, LDAP chose to use neither one nor the other, and chose to define something called lightweight BER. I do not even know why lightweight. Because it's not, it's a mix of BER and DER. Then again, details. Also, it's used in combination with many other protocols like SASL, Kerberos, GSS API, and so on, just to name them. I won't go into the details, of course. Just to say, if you start to implement that, you put the finger into something that will drain you to implement all of that. Yay. Yeah, so this is just a simple request and response. I guess you can imagine what it's doing by yourself. More to go into what I believe to be the interesting part. What can we do for intrusion detection, and why I did that completely wrong? So to implement LDAP, you have to do two components. You have to first implement the low-level parser, which will understand the structures of the protocol and stuff like that, which is independent from SuriCata. And you have to implementation the SuriCata app layer. So the protocol parser and decoder, I did that already many years ago, maybe 2, 3, something like that. And then I worked on the app layer. And I wondered, I was stuck on some problems, and I waited and I waited, and I never submitted anything. So at some point, some guy had enough, and I would like to give a big shout out to Giuseppe, which did the app layer. So I am presenting something that is only partially done by me, and Giuseppe did the app layer that is now merged into SuriCata. So credits to him. So this is an example of what not to do when you're working with upstream. So if you can use that as an example, just take it. So what I will do is stop talking about technical details. I will try to give a few words about what is LDAP useful for, to propose detection rules that are currently not possible. I would like to stress that point. We can't because we did not do all of the work. Currently, there is no detection keyword, so you can do the proposed rules by storing the metadata outside, because the logging features are implemented. So you can filter the logged information and do the detection outside for the moment. But the intention is to add the detection keywords as soon as possible to do that inside SuriCata and do that better, of course. Also, I proposed a few custom tags I just imagined. So any tag can be discussed because it's just a rough estimation of important things or not. I will put on the proposed rules. So, of course, since I implemented the low-level decoder, one first thing I would like to detect is bad encoding. So you can, for example, BR is very complex. There are lots of bounds to check. Every parser in C is what I usually call a piñata of vulnerability. You shake the parser and many vulnerability falls. So it's great for security guys. So implementing the BR parser was just the ideal job for Rust, because it's memory safe. So I did that in Rust. I'm quite happy with it. I used a lot of fuzzing on the parser, found nothing. I was happy. Great. And then I tried to, for example, modify packets, send malicious data to the parser. Okay, it's detected. So SuriCata can detect it, raise, decoder events. Cool. That's easy, that's generic, but to be honest, it has almost no interest. Because, yeah, okay, if someone sends invalid encoding, okay, it's a problem, but we don't care. We want to focus on what can you detect with SuriCata, and not bad encoding is just one form of one possible way to attack. It's not the most used. So let's focus on the rules that will really use the operations from the protocol. So one operation that is important to understand, one request response operation, is the LDAP bind operation. So in the LDAP vocabulary, bind is a way to saying I'm authenticating, so from this moment the connection is bound to this user. You can change that after, kind of unbinding the connection, so I'm becoming anonymous again, and rebind the connection and so on. It's not that used, but user change, but it's possible. So the first state of a connection is anonymous bind, meaning you have no user bound to the connection. So when a user is on a network and the LDAP server is accessible, it can send requests to list the content, and these requests will be anonymous. So detecting anonymous operations is important because it will help you detect what users are just not part of the network and try to list content without having any credential or known user credentials at the moment. So often this comes from misconfigurations for applications. This can be not really a hard error, but it's interesting to detect. So that's why I put it the false positive tag, because you have to investigate every possible alert that is raised and ask yourself, is it normal to have an authenticated sessions, or not? Well, so when you have credentials, the natural way of doing things is to use the bind operation to authenticate. Okay, so LDAP offers an operation that is simple bind. Okay, nothing to relate it to the bind. I know you, Eric. I know you thought the same thing I did. Simple bind has a slight problem. It sends password in plain text, so it's interesting for attackers. So this is the #1 vulnerability, jokes aside, for application configuration, misconfiguration. It's very easy to detect because a simple bind operation is just characterized by some constants, so it will be very easy to detect. And I believe the rule for Suricata will be very easy to write. Any simple bind operation is just a mistake and should be transformed into an alert. So it's quite easy. It's a very generic rule, so yay, at least we can write one rule. Another one is that, in fact, there is TLS, but it's not really used. Even in Active Directory, TLS is not that often used. And why is so? Because in Active Directory, the authentication will not use simple bind, so your passwords are not sent in clear. But in fact, where you need really performance, it's faster to not use authentication. So the logic most of the application use is we don't care for confidentiality. We will just use plain text connection and so on, which is somehow good because if there were encryption, we couldn't write the following rules. So we will just focus on that. So of course we can detect the lack of encryption. And if so, we could raise an alert. That is really complicated to interpret because it really depends on your applications, not only your website or your site, whatever your company. You have to wonder yourself, is that application supposed to encrypt everything or not? By the way, configuring an AD to send only encrypted queries is quite of a challenge. So you may end up anyway with plain text queries, whether you want or not. Also, since you have encryption, and when you also have written a parser for X509 certificates, you are interested in the encryption parameters. So there is two kinds of encryption. I won't, again, go into details, implicit and start TLS. So the goal is to extract the encryption parameter and be able to inspect them. The pull request was sent just yesterday, so it should be fine. Why is it important? Because too many people forgot that it's not because you are using encryption that you're safe. For example, there were many vulnerabilities in LDAP software or libraries because yes, it was encrypted, but the certificate was never checked. So in fact, it was not really encrypted for an attacker doing man in the middle. So be good people think that encryption is not enough. Good encryption is something a bit more complex to do. Also, you can do what is called LDAP injections. So this is similar to, if you know SQL injections. I won't go into the details, just look at the example. Yeah, of course. LDAP has a lovely prefix-based syntax for filters. So you give first the Boolean operation, then the filters, and you combine them. You just have to think upside down again. Maybe more natural for some people. So if there is a query that expects two parameters, and for the first parameter you provide something that has parentheses and will use a kind of a different syntax, the constructed query will look like something like that, and just the first part will be interpreted, and this first part was designed to be always true. So not to go into the details, this is one way of bypassing authentication if you have a web form based on LDAP. So of course, this is injections are interesting to detect. The problem is it requires to understand the application logic because the build filter might be much more complex than what I showed. So you have to build something. Also, in the LDAP data, we have the filter in the form of a complete AST, which is quite difficult to reconstruct, and it's expensive. So we don't want to log, for example, every search filter. It has no interest, but we may want to, for example, detect some specific keywords in the filter. Also, it's exactly like SQL injections. It's quite hard, in fact, to detect, even if the theory is that it would be possible. LDAP servers are also subject to denial of service. And in fact, it can be rather easy because there is a nice amplification possible. You send a simple request that will just a request for the entire tree. And the request takes a few bytes, and the reply will take a lot of time and data. So the server can quickly be under denial of service. So it might be interesting to detect some specific attributes on the search, like for example the whole subtree attribute, which just tells I want to dump the entire subtree of the request. This is not something that applications should do. But hey, we are in the real world, so of course many applications use the whole subtree thing because they are badly coded. So yeah, lots of false positive again. So now I would like to focus on Active Directory. So Active Directory, as I said, is a directory service which is the heart of any Windows deployment. It's LDAP, it's Kerberos, it's a few other things. So you have a different port number that also was in the pull request, the 3268, because you have different operations, whether you are requesting the local domain for your controller or if the controller will forward the request to another server. Also, we have Kerberos ticket. Hopefully, the Kerberos parser is already in SuriCata, so we will be able to plug in the all parsers in the next time. So we'll focus on AD, but what I show could be possible for other things, for generic LDAP. So for what is LDAP used for attackers? Well, the primary use is reconnaissance in the network, meaning the attacker already has some kind of entry on your network, and they are now trying to gather information on your network. So it's an important moment where you want to detect the attacker because, okay, they are already here, so it's important to detect them. But at that point, they probably do not have changed many things or performed many actions. So it's a good moment because it's the early stage often of the infection. So why is it difficult compared to other kind of detection? It's difficult because, well, the activity using LDAP is not malicious. The queries that will be sent are not specific queries. They are regular queries, something that other users are probably sending at some moment. So we are looking at legitimate activity. So it's hard to write signatures for legitimate activity on that. So we are looking at MITRE TTPs, which are group permissions discovery, account discovery, domain interest discovery, and so on. So this is the kind of information that the attacker is trying to gather using LDAP. So more precisely, what kind of request is using the attacker to do that? Well, it could be, as I already said, anonymous request. So you will have something like, I want, for example, all of the account names. So this is a request to list the directory users. But it's not only the users. You can list groups, you can list the computers that are part of the network, you can list the user account attributes, meaning who's a network administrator or not, for example, which is a very interesting information for the attacker because now they know which account they want to compromise first. They also list, you can also list the domain password policy, so this can also help attackers to configure, for example, tools that will try to attack the hashes, knowing the policy. So there is something good here. It's that Microsoft did some changes, and now Windows Server 203 will require authentication. But as I also work in an agency where we have different, say, customers, I know that not everybody is using recent Windows Server, so that's why this kind of rule might be interesting anyway to write. So we might want to write rules to enumerate, for example, to detect enumeration, account enumeration, which is complementary to DCE, RPC rules, or SNB rules that would do the same. It's not that easy because, in fact, the search queries are, they might be obfuscated. I mean, given the natural form, it's already kind of obfuscated, but you can do something even worse. So it might be complicated. So maybe a way to detect that is to create a canary account and detect when information about that account is returned over the network in reply of a query, because that, again, is not something that should be seen on the network. So usually the second step of an attacker, when they have credentials, is to then again completely list information. So domain, again, French, name, administrators, and so on. So this kind of request can be detected because then, again, they are using the whole subtree search scope. They are returning many, many items. So We might want a way, for example, in Suricata to detect the number of entries returned from a request, because when this number is above a threshold, that might indicate some request that is not expected. Kerberos ticket. So Kerberos ticket provides much information about the user. As I said, in Active Directory, the authentication is based on Kerberos. So in LDAP, you will have the Kerberos ticket provided at some moment. The Kerberos ticket contains information which is related to the user, like the principal name, which is kind of the same as the login. So we can check if the principal name is the same as the bind DN that was used on the connection. So to correlate different protocol and see if the same information that was provided on different information, on different requests. This is important because that will help you detect attacks based on, extracting a hash and reusing it, or stealing a Kerberos ticket. And this will help you detect that because the name in the LDAP request will not match the Kerberos. For example, if you steal the ticket for your host machine, you will be able to detect that it's not normal to do queries with that ticket for a regular user. There may be some slightly complicated things to do because I just wanted to show you, there is nothing I will really comment on that, but I just wanted to show you the levels of insanity you have to dig into to extract information in that kind of protocol. So just imagine yourself writing a Wireshark filter to get the principal name. There is something like 25 layers, so that makes, in the filter, that would make a lot of a dot. It's kind of funny to do. But the good news for you is that we did that. So you don't have to do that. In fact, what is more complicated for us is that we are still trying to think about how we will log information, so it's not hidden above the same stack of different layers, and so it can be really useful for people using tools to use the information. Also, the attacker may want to use LDAP to try brute force passwords, and this is interesting for an attacker because the password rules, and especially the limit of number of attempts for a password, may be different on Kerberos and LDAP. So it happens that you may, for example, only try 3 times before the account is locked on Kerberos, but on LDAP you have as many tries as you want. So again, it's interesting to detect if there is a huge number of bind operations that are attempted at a moment. I believe it is not too difficult to detect from SuriCata's point of view. And there are limits and barriers. Like, for example, so I won't explain what it is, but you can configure your Active Directory in a very precise way to use channel binding and signing, which are security features provided by Microsoft to improve the security of LDAP queries. These features will end up in almost everything being encrypted. So, of course, if the queries are encrypted, the rules we are writing won't be that useful. So this is a very common situation when trying to do internal network monitoring. So at that point, I'm tempted to say, even if it's SuriCon and maybe the team will throw something at me, but Suricata may not be detecting everything. So at that point, it may be easier to use other solution like host-based detection as a complementary method. That is easy to say. In practice, it's very complicated because you have to do correlation that is not that easy to do, and you have a ton of information to interpret. So, yeah, the theory is easy. In reality, it's a different problem. So, I'm looking at people. No one's asleep. Okay, good. I hope I did not. I was not boring. I'm trying to, as I said, focus on different presentation of what with the LDAP app layer in SuriCata we will be able to achieve. So. Internal security supervision is a kind of supervision that requires different tools, different protocols, different applications to handle data. I cannot stress enough the fact that, for example, if you want to log everything, every single LDAP request and so on, it will probably not work because there are so many queries per second that you will flood your logging system very quickly. So you have to filter things, you have to be a bit more specific about what you will do. But what's already in the app layer implemented in SuriCata is logging. So every metadata I spoke about is available as logging information. So you can do detection based on the metadata. And as I said, detection keywords are coming. So again, what is difficult in this kind of detection is that it's malicious use of legitimate features. So it's a different kind of detection. I believe a simple rule is not really enough to detect easily an attacker. But still, we can do many things. We can detect stuff, and with that, improve the security a lot. So yeah. This is LDAP in SuriCata. It's just one step. I would love to hear some feedback about people that are interested in that particular feature, if they are expecting to be able to do something that was not in these slides. Because I know that every people will use the Active Directory detection features in a different way. So really, if you want to get in touch with me and discuss about possible detection points, I'd be glad to hear from you. So it's a very, very long to-do list. I hope to do that very quickly. You can throw me things if I forgot to do that. But then again, I was not the only one that worked on it, so credit to Giuseppe. I'll continue working on it, of course, and we'll be making commits in the next few days, week, whatever. Thank you for your attention. If you have any questions.
So thank you for the great presentation. The question I have, all of these approaches that you mentioned, are there already SuriCata rules, or they are like separate, or they are part of any rule set that is provided? How I in my environment can apply all of these mentioned approaches?
As I said, we still have to write the keywords to just express these rules, so it's currently not exactly possible, but the greatest part of the work was already done because we now have all of the information to write the keywords. So for example, the type of authentication, be it anonymous, simple bind, SSL, etc., is already available. So we just have to create the glue between the keyword and the data that is already inside the app layer. So yeah, I know the detection keywords are not ready yet, but soon.
And the second question, what about SAML?
Yeah, one more thing in the to-do list. No, yeah, it's not already done. I have to finish what I already started, but I think about it. It's on the list.
Maybe it's worth to mention that this information are relevant, so you can look at that. Sorry, I was saying maybe it's worth to mention that this information are available in EVlog. So basically what you are missing is the detect keyword, but if you inspect LDAP traffic, you can get all this info you need.
Yeah, exactly. GTP, as I said, everything is already available as a metadata log. So if you log the metadata from the queries, you have all of the information to do exactly the same thing in your dashboard.
And just to add, you can write signatures today on the LDAP traffic. It's just that it's not broken out with keywords, right? So you just have to do it as like stream. It's a little bit gruesome, but doable.
Yeah.
I was just going to make a comment because we've been kind of going through a lot of stuff on our side, and LDAP is it's pretty interesting because like even you would think that, oh well, you know, if someone is asking for like the whole directory, you know, that would be something that you could trigger on, but the reality is like Outlook does that. When you like open the address list, like it'll ask for not everything, but you know, so much that you can't just simply rely on rate limits and stuff like that. So I just found that interesting. And also on the host side, one of the challenges is like with Kerberos, there are Microsoft logs for all the tickets, but with LDAP, there isn't like a good way to debug and get all those logs. There's some debug option rather, but like they're like, don't leave this on, it's horrible. so really, I feel like the network is like it's probably where we make our last stand on LDAP.
Yeah, I believe we will be able to provide more information than what is currently available from the debug from Microsoft, but regarding Kerberos and LDAP combined together. But yeah, it's you don't have everything. And as I said, and you exactly mentioned that, these are legitimate requests. So some applications are using these features that I described as unusual or not properly intended. So sometimes you have to make exceptions on your detection rules because of these applications.
Yeah, and just one last comment. Just in terms of encryption, even though it does pose challenges, I would say that there is still value. I'm not sure what we do on the metadata side, but like there's still things that you could detect by the way that, you know, something is negotiating a connection that might distinguish it from, you know, like legitimate users. Like if you have tools, you know, almost like JA3, but for you know, the handshake and stuff like that. So I'd encourage you to think about that as well, because there could be some good value there.
Yes, and since so it's true, and for encryption traffic, since we are pushing the information to the TLS app layer parser from SuriCata, it will already do some work about everything on the encryption. So much of the stuff will be available. So that is cool, I believe. So you'll have J3, J4 hashes.
Hey, Pierre.
Yep.
So, thank you. I guess LDAP is a bit less of a mystery, but still big things to dig on. One comment for us as a team, I guess, is that I saw with the Wireshark capture that Kerberos is embedded into LDAP, and Kerberos is already a app layer protocol in SuriCata, so I guess that we should improve also in multi-app layer protocols in one flow. And my small question was about the user brute force password trying.
Mm-hmm.
Would it be the same for password sparing attack, where I tried the same password for all the users that I have been enumerating in the domain?
Yes, yes, you will be able to detect that, but depending on the number of queries and if only the user is varying, but you will have access anyway to the password that is used. So, well, the SSL encrypted version of the password. So you might be able to detect reuse of something. There might be some difficulties to do that properly. That's it.
Okay, thank you.
So you mentioned that the logging volume is so incredibly high in busy deployments. Is there a lot of repetitiveness that we could maybe catch with config rules that disable logging combined with data sets to try and deduplicate what we log?
Yeah, so currently the logging layer is configurable regarding to the operation. So for example, you can say only the bind request and response operation are interesting. I don't care about the search request. So that you can already do with the current implementation. The difficulty with what you would like to do is that, again, a single session in LDAP is a sequence of different requests and responses. So it's not one thing that you would want to filter out, but a specific sequence. So I don't know how to express that properly in the rules, but you might be able to find something, quite compact, just to say, for example, if there is a bind then search, then something I would like to ignore that. I don't know. That's a possibility.
Thank you.
Okay. No.
Yeah, I like the approach of Canary. That can be interesting. Are you planning to use to introduce a keyword like a LDAP DN, where we can really be access to the DN of object to do that, or do you have something else in mind?
Yes, the DN is already logged in the eve.json file. So, in fact, you could already have what you want to detect. At least, for example, a login attempt using that account, you can perfectly detect it today based on the metadata that is logged. So yes, it's based on the bind DN information, and the DN may be in the search replies.